Okay, so this is video 3 for the Engine2 FinalSprint. So for the first one, it was the visualizer and all the stuff associated with this. So obviously there's a lot more now because it used to just be the B-sphere. And now it's got the OBB and AABB. And everything is done here through the command pattern. With the submitting of collision volumes into different command lists, and then having both the recycled and submitted lists for each one, so that not creating a bunch of new ones every single frame. So I'll get to showing all this in just a second. But yeah, so there's lists, and then of course, showing allows the user to visualize a single B-sphere here. But then also there's a show marker function, which I think, is here in the tools. There's no line, just because it was taking too much time to put in, and I ended up getting the collision stuff working anyways. So there's just the marker for now. There's also the visualize all function, which basically goes through all of the lists and executes them, and then takes them out of the list, or takes them out of the submitted list and pushes them into the recycled list, so that they can be used, and then clears the submitted list. So it is that for the B-sphere, the AABB, and the OBB. So that is that function. The delete here is working with the terminate. Nothing is supposed to go in the nothing should go here in the destructor. Everything should be run through the terminate. So then next I should just show the commands. So everything comes from the visualize command. Pretty sure these inherit from the base class there. So basically it's just the constructors with the execute and a set world position and color together with a single function here. And then the execute is just rendering whatever volume that is. So these are pretty much all the same here for all these guys. Next up, and then there was the colors class, which just, I don't have too many, but it was enough to get it all working. So just some color helper class there. Next up was the math tools. So I'll look at that real quick. So the math tools, I'll run through all these real quick. So there's of course all the intersect functions, and then a compute AABB that was used a lot, and then a compute B-sphere, and then a check intersection and projection max, which were used for the OBB functions. So I guess I should just go ahead and start from the top. So there was a generic intersect function that was using two collidable groups, and then these would go ahead and figure out which one of these intersects to use. So then of course there's the B-sphere from last quarter. There's the AABB to AABB function, the OBB function. So I know in your thing here it says it shouldn't, like, none of the functions should be too large. I know this part here is stupid. This part's dumb. But the rest, like, it's a little bit longer, but I just followed along with the notes that I took from the class last quarter, so I wasn't really quite sure how to, like, squeeze this down a little bit, but basically it was just getting the running through the 15 tests here with the different axes. Let's see if I can remember. There was the 2 length projections. Yeah, I'm forgetting exactly how the function worked. But I just remember when I was doing it, just following along with the notes that I took from class. So anyways, there's that for the OBB. Then there was the AABB to B sphere, which we're just using the clamps. Next was the AABB to OBB, which is similar to the other one. I guess technically I didn't need to have this since it runs the collision on both objects, but it's there just in case. Then there was the B sphere to OBB. Again, using the just the clamping of the X, Y, and Z there. Next up, there was just a compute AABB function, which basically took in a model and returned a min and max vector, so like the 2 corners of the AABB. So basically it just runs through the model and checks the X, Y, and Z position and creates the AABB from that. And then lastly was the compute B sphere, which is pretty easy. Just getting the center and the radius times the scalar. So that's good. And then these are just the check intersections for the OBBs. Let's see. So I think I'll put those 2 together, and then the next one will be the terrain. Cool. Thanks.